Hello Prealgebra students, this is lesson 51 and today we have two different objectives. The first one is how to use negative exponents and really kind of understand them, and then part B is how do you write small numbers in scientific notation, which the short answer is you use negative exponents. So that's why they're kind of in the same lesson there. But let's just real quick think about exponents. If I said 10 to the first power, that means 10, right? 10 squared means 10 times 10 or 100. 10 cubed means 10 times 10 times 10 or 1,000, etc., etc., etc. So if I wanted to move down this list, I just multiply the previous number by 10, right? 10 times 10 gives me 100. 100 times 10 gives me 1,000. 1,000 times 10 gives me 10,000. So if moving this way down the list, I multiply by 10, how would I move up the list? Well, by doing the exact opposite would be by dividing by 10. So 10,000 divided by 10 gives me 1,000. 1,000 divided by 10 gives me 100. 100 divided by 10 gives me 10. So that means if I wanted to continue this on up, what would be the next one? 10 to the 0th, then 10 to the negative 1th, 10 to the negative 2, etc., etc. These would be, well, let's see. If I did 10 divided by 10, I'd get 1. 1 divided by 10, I end up with 1/10, which is 1 over 10 to the first power, or 0.1. If I divide that by 10, I get 1 over 100, which is the same thing as 0.01. So I'm just following that same pattern up. The same thing would hold true over here if I use 2's. And the next one up would be 2 to the 0th, 2 to the negative 1, 2 to the negative 2, etc. 2 divided by 2 is 1. This would be 1/2. This would be 1/4, which is the same thing as 1 over 2 squared. Okay. This is equal to 0.5. This is equal to 0.25. Okay. So you can kind of see how that pattern works. So two things I guess we need to note. First of all, any number to the 0th power is equal to 1. This is important to know. You might want to put that in a quick reference if you want, if you didn't already know that. And then the other thing is that x to the negative n, that's like these up here and up here, doesn't mean that it's some negative number. It just simply means that it's kind of on the wrong side of the division bar. So this is the same thing as 1 over x to the n. So let's try that real quick. I'm actually going to do, okay. So example 1 here says which one of the following does not equal 10 to the negative 3? Well, following that example we just did, 10 to the negative 3 is actually the same thing as 1 over 10 cubed. So this one is the same as that. Well, what is 10 cubed? 10 times 10 times 10 is 1,000. So it's going to be 1 over 1,000. So that's the same. And then if you actually divided that out as a decimal, you'd get 0.01. That's that one. So the one that does not equal would be D. Okay, so it doesn't mean some negative number. It means it's, so all three of these are equivalent to this. Alright, example 2. Remember here that whenever the bases are the same, you simply add the exponents. So this would be 8 to the negative 2 plus negative 6. Well, negative 2 plus negative 6 is negative 8, so this would be 8 to the negative 8. So what goes in that box is a negative 8. Remember, you subtract the exponents on when you're dividing, so this would be 14 to the negative 6 minus a minus 9. That's the same thing as saying 14 to the negative 6 plus 9, right? Minus a minus, so add its opposite, which would be 14 cubed. So what goes in the box is a 3. Example 3 just says simplify this. This is the same thing as saying 1 over 3 cubed. Remember that rule we just talked about? Pull down to the bottom, change its exponent to positive. Well, that's the same thing as 1 over 27. Take a look at my thought bubble if you have questions on that. Part B is a little bit different. Notice the exponent on this one is the negatives in the exponent here. Here the negative is in the base. Okay, so this one means negative 3 times negative 3 times negative 3. Well, negative 3 times negative 3 is positive 9. Multiply that by the negative 3 is going to give me negative 27. So notice the difference in those. One of them's in 1 over 27, the other one is negative 27, depending on where that negative sign is at. And then this one says, simplify this. So this is kind of like example 2a. We're just going to add those exponents. 4 to the 3 plus a negative 3. That's going to be 4 to, well, 3 plus a negative 3 is just 0. So 4 to the 0th power is 1. Alright, write with only positive exponents. So what we're going to do is I'm just going to draw a division bar in here. And anything with negative exponents I'm going to bring down to the bottom. So this one comes down, and this one comes down. So I mean this is going to be 2. Here's that y, x squared, and a z. Those are the ones I didn't circle. On the bottom, I'm going to have an x to the first power and a y squared. Those are the ones I did circle and bring down to the bottom. So now I can simplify these two. All right, x squared over x is just going to give me an x. So I'm going to have that 2. I can also simplify those two. So that's going to, the x squared over x is going to just give me 1x. And this one, the y's will end up with a y on the bottom, so I still have a z on top and just one y on the bottom, right? Think about like y over y times y. That would reduce, I end up with a 1 over y. So the y stays on the bottom. Okay, so this would be my answer here. Alright, looking at this one over here, which is quite similar, except for notice that this 2 is grouped there with the x. So that means this number is going to come down to the bottom, and this one's going to come down to the bottom. So on top I have a x squared and a y cubed. I changed the order just because I'm writing in alphabetical order. On the bottom here I'm going to have a 2x to the first power, they're both the first power, times y to the fourth. Those two will reduce, and those two will reduce. So this gives me, on the top I'm going to have an x, because there's 1 here, so 2 minus 1, positive 1 on top, there's a 2. And then there's 3 of them up top, there's 4 of them on the bottom, so there's going to be a y on the bottom. That's going to be my answer there. Alright, so this is kind of moving on to the second part there. It says write in standard form. Remember that this 10, it's negative 4, is the same thing as 0.0001. Right? Or essentially I'm dividing by 10 to the 4th power. So that means I'm going to move the decimal place 4 places to the left. 1, 2, 3, 4. So I'm going to say 0.00034. This one, negative 3, so I'm going to move to the plate to the left 3. 1, 2, 3. It's going to be 0.003456. And notice the instructions said write it in standard form. That just means don't write it in scientific notation, just write it as a normal number. Now this says the other way. Here's a normal number. Write it in scientific notation. Remember then I guess I want to move this over 1, 2, 3, 4, 5, 6 because I want this number to be between 1 and 10. So this is going to be 1.2 times 10, and this is to the negative 6. So kind of how I remember that is if it's a big number, I have a positive exponent. If it's a little number, I have a negative exponent. This one here, I need to move it over 1, 2 places. Just kidding, 3 places, because I want that to be there. So it's going to be 7 times 10 to the negative 3. It's a small number, negative exponent. Your homework is there on page 350. You're going to do the practice set, all 51s. Notice I did not require you to do 50s. And then 3 more of your choice. Good luck.